One of the things we all know about .NET Core is the fact that it's not, generally speaking, compatible with .NET Framework, so that they've decided at this point they're going to do a complete rewrite, and although there's lots of similar features, they are new implementations. There's no guarantee of backwards compatibility, which can be very irritating if you've got existing framework applications. There's no easy migration path through to core. It can be done, but you've got to make some changes. But what it also means is that because there's no need for backwards compatibility, the developers of .NET Core have taken the opportunity to introduce a few minor changes, improvements to framework that couldn't have been done within framework, because although they're improvements, strictly speaking, they're breaking changes. And I thought we'd just look at one of these this week, which is how they've changed the way that the random number generator works. So random number generator we've been using in a number of the examples I've been showing you for the rock, paper, scissors. And so if we take a look at one of the earlier versions of that, this is before I'd introduced things like the strategy pattern, we can see we just had our basic signs, rock, paper and scissors, and a matrix for who wins what. And then our player very simply had a random number generator. So it generates a random number between 0 and 2 in this case, because we've only got the 3 signs, rock, paper and scissors. And that's what's used to throw. And something that I was very careful to put in, even though I didn't mention it at the time because it wasn't really relevant to what we were looking at, but I put it in there, was to make this random number generator static. And if we have that as static, and in our program we've got 2 players, Sally and Harry, then when we run this up, and we'll have, say, 5 throws, you can see we get what looks like a reasonable random result. So there was a draw, then rock beats scissors one way, then rock beats scissors the other way, so on and so forth. But if I were to change that very slightly and go back into the player and simply remove that static, so now Harry and Sally have got their own random number generator object each rather than sharing one. And then if we run that up, then if I put in 5 throws, we can see they get a draw every time. Rock, rock, paper, scissors, rock, doesn't matter which one. It's still randomly choosing rock, paper or scissors, but it's choosing exactly the same for each one of them. And this is a problem that's been known about with the random class since it was put in with version 1, and that's why we get in the habit of making it static to make it work. But let's have a look at why that's not working. And in fact, just to separate that out, I've put in this separate project called random numbers that we can have a look at what's happening. And essentially what we can do is this. If I create here a couple of random number generators, so I'll say random R1 equals new random, and then random R2 equals new random. And then if I just say for int I equals 0, I is less than 10, plus plus I, and then we'll print out just the next random number from each one of them. So I'll put in R1 dot next, and we'll have that in the range 0 through to 99, so that's the exclusive upper bound. And then we'll do exactly the same thing with R2. And then also set that as our startup project. And then if we run that, we can see we're getting exactly the same numbers each and every time. And that's just a slightly simpler manifestation of exactly the same problem. And actually what this is a race condition. You may be familiar with why this is, but if I were to just do this, if I were to just say thread.sleep for 10 milliseconds between the creation of the 2 random number generators and then run that, we can see we're getting different numbers, we're getting them randomly generated. And so it's a race condition because it depends very much on the fine-tuning of the timing of the program, whether you get one set of behaviour or completely different behaviour where they're getting the same value every time. Now the random class is what is known as a pseudo-random number generator. Now that's not the only way to generate random numbers. Quite often it's done physically. So for example with the National Lottery, when they randomly shuffle the balls to get the numbers, that's a physical approach to doing it. Also when we had things like the Ernie computer that's used to draw premium bonds, the electronic random number indicator equipment, that actually used a physical method. Originally it was signal noise in neon tubes in the computer. It's varied in different ways, but those are physical approaches. But what we have when we're writing a program, we can't in a normal computer rely on those physical ways of doing it, so we have this pseudo-random number generator, which is a mathematical sequence that, although in a sense it's entirely predictable, it jumps around from one place to the other. Here's an example. I've written this pseudo-random class for myself, and this is actually based on the very first algorithm that was devised for this, which was a thing called the middle square method, devised by mathematician John von Neumann. Now, it's not a particularly good one. It has problems that it doesn't produce a particularly well distributed random series, but it shows what's going on. So what I've got here is we will create in this program here, we'll just get rid of that, and then I'll create an object to this pseudo-random class. And key thing about pseudo-random number generators is they always need a seed value. So let's initialize that with that seed value. So here I'll just nick that for loop, and this time we'll just do console write and then rand dot next. And if we then put a break in next, we can see what's happening. So remember, the initial value I had in there that we passed in the constructor was 1, 2, 3. So the first thing we do is square it. So that will give us a new value of 15129. Now we need that to be padded out. In this case, padded out to 8 digits in all. So I turn it into a string, and with that D8 formatting, we pad that out to 000155129. And then, the reason it's called the middle square method, having squared it, from the 8 digits of the square, we take the middle 4 digits. So when we do that, that gives us 0151. We then turn that back into an integer. That's the value we return, but that's also the value we use for the seed the next time around. So next time we come in here, then the value is now 151. That gives us a different result, and it keeps going round and round like that. And so at the end of all that, if we just run that, we can see we are getting what could be judged to be random numbers. As I say, it's not a particularly good generator, but it certainly jumps around, shows us the basic idea of what we've got. And the idea is, if I were to put in a different seed, so 3, 4, 2, 1 say, then we get a different set of these random numbers. But if I use the same seed, so remember the first number there was 7032, then we get exactly the same result. And that's very similar to how our random class works. It doesn't use the same algorithm because that's a really lousy algorithm. It's just there to show the idea. In fact, it uses an algorithm that was devised by a mathematician called Donald Knuth. That's K-N-U-T-H. And it's a much better way, but it's the same basic idea. It just iterates through, bases each new number on the previous number, and begins with a seed. So if we put that back in, if we were to put the same seed in these two, then the behaviour would be entirely predictable. If they've got the same seed, they're going to generate the same sequence, and so with that, we're always going to see they get the same set of numbers coming out there absolutely every time. So not only do they both get the same numbers, but they get the same numbers every time we run it. And that can be very useful, particularly when you're doing testing, because if you want to test, even though in the real world you may want to use random numbers, you want your tests, your unit tests particularly, to be predictable, and so you might want in those circumstances to put that hard-coded number in there. But when it comes to actually playing your game or whatever it may be, then obviously you don't want it to be the same every time. And so the trick that's done is we seed off the current time on the machine we're running on. And so if we seed off tick count, that's going to be not a random number, but almost random, because it's going to depend very, very precisely on when we run this. So if I run that, we now see we're getting different numbers. And the second set of numbers with the fixed seed are always the same, but the first set of numbers are going to be random. And actually, that's what we do if we just call the default constructor. So automatically it calls that tick count, and so we get the same sort of result. And now I think we can see what the problem is, because the tick count is only down to the millisecond, which is a pretty big thing in programming terms. So if we were to put tick count in both of those, the chances are, because they're subsequent lines of code, that they're going to be the same value. And so you can see we do get the same value. That's why if I put my thread.sleep in there, even if I only sleep for 10 milliseconds, that should now be plenty enough that we're getting different results from those two numbers. And that's exactly the problem that we had back in our program for rock, paper, scissors, because here we're creating Sally and Harry within a fraction of a millisecond of each other, and therefore their random number generators, because they've each got their own random number generator, is being created within the same tick count. And so if we switch back to running that as our program, then that's why we always got exactly the same results, which is why it's a better idea to actually make that static. And that means there's only one creation, and so rather than getting parallel numbers in two identical sequences, we get subsequent numbers in one sequence, and therefore they are going to be different and appear to be random. So now when we do that, then we can see that that's doing proper random behavior. Worth putting a couple of caveats in at this point about random number generation. Using that random class is okay for basic games programming, that sort of thing. It is definitely not okay for any situation where you need a random number generator that you're going to be using for cryptographic means. There is a separate cryptographic generator for that we can see is actually the RNG crypto service provider, or under system security cryptography random number generators. So those are the ones you should use for crypto. But if you're doing basic gaming, maybe not even if you're doing casino type gaming, they want to be careful because of financial risk. But certainly for ordinary gaming, then the random class is an okay way to go. One other thing to mention, that when I was first working on the rock, paper, scissors program to show you back in an earlier video, I did it in .NET Core because it's the modern version, it's the way we should be going. But when I did that, I discovered something odd, because what I've actually got here, you can see I was doing that in Framework, but we also in Core have exactly the same program. So if we just look at those, that one is in Framework version 4.8, whereas this one is in Core 3.1. And so if we set the core to be the startup program and then just change that so we're doing it wrong, when I run that up, we can see they're not getting the same value. So remember, if I run that up in Framework without it being static, then they always get exactly the same because they're both using the same random sequence. But in Core, it didn't work, which is a bit of a shock to me, having spent so long in all my previous programs, whenever this has come up, making sure I have a static random number generator. And as I mentioned back at the beginning, this is something they've actually improved in Core and deliberately taken this opportunity because it is, technically speaking, a breaking change. Although it's hard to imagine anyone relying on this feature, that if you create them at the same time, they will have the same sequence. It would break if someone had relied on that. So what they've done in Core made it slightly different. The random seed is not simply the current tick count. The random seed is taken from another random sequence. So if two random classes get created one after another, they will be seeded on these different numbers from a random sequence, which is a big improvement. It means that we don't have to worry about this. We could still, if we do want them predictable, if I were to hard code that with a value in there and now run that, we can see they're now drawing because they've both got the same sequence, the sequence based on the number 5. But when we want them to be random, then we can see that works correctly. So that's an improvement that went in with .NET Core. It's a slight breaking change, so that's why they couldn't put it in earlier, but I think everyone would generally agree it's an improvement. One last thing to mention on this, it does show us something about the relationship between Core and Framework and .NET Standard, which is something that can be a bit confusing. because standard, really we only notice it when we start thinking about core. But standard, as the name suggests, is simply a standard. It specifies what classes, what behavior is available to any particular implementation, and both .NET Core and .NET Framework are implementations of the standard. And you'll notice what I've done here actually. All of my code for the actual game logic, so particularly that player and the random number generator we've been looking at, I put in this project, which is a standard 2.0. Can't be 2.1 because that's not supported by Framework, but standard 2.0 is supported by both Core and Framework. So that is a standard library. And remember what that means is it's not tied to any particular implementation. It's just written against the standard. The choice of implementation comes in later on. So when we look at this code, we can't actually say how that random number generator is going to behave. The behavior only gets decided when we either run it through a dependency from a core application, so remember that one's core 3.1, or from a framework application. So just a little corollary there really. We can see that in that case where there's been a subtle change in the behavior, in this case of the random class, but there are others throughout the standard as well, we can see that the choice of how it's going to behave does not depend on the version of the library. If we go for the standard library, it depends on the version of the program that's running that library, here either framework or core. So, two things to take away from that really. One is that subtle change in the way that random works that I don't think is going to hurt anybody, but certainly took me by surprise because having learnt from my mistakes in the past, I'm careful to make my random number generators static. But also a bit of an insight into the way that core and framework and standard relate, and we saw that the same standard library behaved in slightly different ways depending on whether it was run from a framework or a core application. Hope you enjoyed that. Links to the source code as ever in the description below, and please do subscribe and see you next time.